Hello, this is a short video on using what is called the custom design platform in JMP. Before viewing this video, I do recommend you read through the set of notes on custom design, which are also not very long. And what we're going to do is see how we can use a particular platform in the JMP software to design custom experiments in a relatively easy fashion. So there are many ways or platforms to generate designs in JMP. They're located under the DOE menu. So we click on DOE. As you can see, there are many types of designs, and the first item is custom design, because this actually is fairly easy to use, although I will add there are many aspects to it that are well beyond the scope of the present discussion, but you'll find this very useful, particularly as it pertains to designing an experiment for the anodizing process, DOE, that the team is going to run to try to find settings of factors to optimize the process. In other words, to get much higher yields. So I'm going to go to DOE and I'm going to open up custom design. And more or less the design of experiments platforms in JMP have some similar structure, although there is a great deal to custom design, as I said, that can lead one to design very complicated experiments, but it also is a very nice platform for just generating relatively simple experiments. First, when you open it, you will see there is an add response column. Basically, you can add responses, and in any of these windows, if you simply click on a name, you can type over it. So generically, it's a Y for a response. You can simply click on it and give it your own name. Then you can add factors, and this is where the custom platform can become somewhat complicated. So click on Add Factor, and notice there are a number of types of factors. Some of these we have not gotten into really, and it really is beyond our scope for the current discussion. So I'm going to say add a continuous factor just to illustrate. So generically it's called X1, and again you can type over the name. So I'm going to call it anodized temperature. And then you'll see a box where you can change the high and low settings. Generically you get -1, +1, but you can type in whatever the actual settings are for the experiment. So I'm going to remove anodized temp. The reason is I've previously filled out the response and the factors table, and once you do that, you can actually save these tables for future references. Remember, there are 4 critical to quality characteristics or responses that are of interest to us: thickness, L star, A star, and B star. So what I'm going to do in the main report menu to the left of custom design, I'm going to click and I'm going to say load responses. So this is a JMP table that I've previously created, and anyone can do this if they want to, so you don't have to constantly go back and type everything in. So I'm going to open Anodize Custom Design Responses. Okay. And notice what it's done. It's put in the 4 responses. All of them we wish to match a target. Again, when we talk about optimization, and I'm going to talk a little bit about this in a moment, basically there are 3 goals. I either want to minimize something, I want to maximize something, or I want to match a target value. So recall, in the analyze phase, the team actually established targets and limits for all 4 of the CTQs. So that information has now been entered for me. Next, I'm going to load a factor table. So I previously filled out a table with all the factors. And notice that now there are all my factors and the settings, the high and low settings that the team selected for each one. So at some point I had to manually enter this information, and once I've entered it, you can actually go to the report menu and you can actually save factors and responses to a data table. Now, what's interesting about custom design, it also lets you specify what are the various terms or effects that you want in your model. As an example, as a minimum, I want the 5 main effects. But I'd also like to look at some interactions. Remember, we represent interactions as cross products, and that is actually mathematically how they're calculated. Again, we go into more depth in a full design of experiments course, but it's relatively easy to understand the concept. There's also something interesting that goes on. The 3 anodized factors, anodized, temperature, time, and then acid concentration, are in one tank. And these factors, can only interact with each other, and they would contribute to thickness. There are 2 factors in the second stage, or dye tank. The engineers know that the 3 anodized factors cannot possibly interact with the dye tank. They're completely separate processes, so in general we do not have to worry about interactions between the 2. They're completely separate. So when I specify a model, I may want to add interactions. For instance, I'm interested in adding the interaction of anodized temp, so I go to the factor table and anodized time, click cross, creates the cross product. And then I'd like to look at the interaction of anodized temp and acid concentration, so again I create the cross product. And then finally I'd like to look at anodized temp and the interaction with acid concentration, so I'll cross that. Let me expand the window here for you. And then finally I can look at the interaction of dye pH and dye concentration. So these are the only effects that really can occur in this experiment. 5 main effects and a set of 4 potential, what we call 2-way or 2-factor interactions. Remember that at most the team can do a maximum of 12 runs. Well, JMP requires a minimum of 10, to run the experiment. And without going into a lot of explanation, I'm going to add a couple of runs called center points. Basically, these are 2 different trials where all 5 factors are held at the midpoint of their ranges. These are used for a number of things, including a basis for replication. So at this point, I've said how many runs I want to do, which is a nice aspect. By the way, a minimum. This is a nice aspect of the JMP software and custom design. So I've specified the factors, I've specified the responses. You can have as many responses as you want. And then furthermore, I've specified the number of runs, and then I'm going to make the table. So what JMP is doing, it's actually searching for a design that will meet all of the requirements that I put forth. Again, how it does that is a topic more for a full design of experiments course, and then I make the table. We make the table, some interesting things actually occur. Notice in the upper left-hand corner, we have these set of scripts, one called screening, which I'm not going to use, one called model. If I run it, the fit model window opens, and we're going to get into fit model in just a moment in another recording, and there's the model. So I have actually the entire model, and JMP has remembered what I want to estimate. And then finally, notice where it saved this DOE dialog. Just click on that script, select Run, and what it's going to do, it's actually going to reopen the custom design window, the entire dialog window. So if you wanted to, I could go back and change my mind. So I could just simply say back, and I could go back and make changes. So once you set up the DOE, your factor table, response table, and you make the data table, it turns out that the data table contains this important script that lets you go back if you want to change things. It makes it much easier. So I'm going to go ahead and close this since we have already run this experiment. And again, basically that was a quick overview of how to use custom design. Again, it's pretty easy to use. It can do fairly basic, straightforward designs. It also can do some fairly complicated designs.